Welcome back everyone to my channel Chemistry Made Simple for Neet. I am Dr. Radha Subramaniam with a PhD in chemistry. So I hope all of you would be very busy in preparing for the upcoming Neet exam scheduled for July 17, and always remember that in order to crack Neet you need to make sure that you try to clear your basics first and then try to solve the previous year's question papers. If you do not get the right idea on the different topics, then it would provide very difficult, or it proves quite difficult to score good marks. Then you should try to work on your speed as well. In other words, time management is very important, where you have to make sure that it does not take much time to work on different questions. This surely will help to make you stay positive and confident, where you never have to get disappointed at all. So it's very important to be clear about the different concepts. So that is why towards the end, now the time is very crucial factor. We've got only just around 2 months time to cover or revise all the portions. So at this point of time, the quick revision videos which I am uploading, I think would be very beneficial and useful to all of you. So please share it with your friends as well, and let them also take benefit of these videos. Okay, now today's unit we are going to go through a quick revision of electrochemistry, unit 3, Ncert, class 12. So you know what is meant by electrochemistry? It is the study of production of electricity from energy released during spontaneous chemical reactions, and this electrical energy is brought about by the non-spontaneous chemical transformations. So this is very important subject both for theoretical and practical point of view. So many metals like sodium metals, then as well as sodium chloride, chlorine, fluorine, and many chemicals are produced by electrochemical methods. Now batteries, fuel cells, these are all, they convert chemical energy to electrical energy, and which is used in large scale in various instruments, devices and all. And also the reactions carried out electrochemically, it is energy efficient and thus polluting. So thinking of all these points, the study of electrochemistry is very important to create new technologies which are eco-friendly. Also, if you just think of that, the transmission of sensory signals through cells to the brain and vice versa, and communications between the cells are known to have electrochemical origin. So this is a very vast subject, but we are going to cover only some important concepts from this lesson. Okay, so first, as I already said, electrochemistry is the study of production of electricity from energy released during spontaneous chemical reaction and use of this to bring about non-spontaneous chemical transformations. Okay, now already you all might have learned about oxidation and reduction. We also learned that about that in redox reaction. You just go through the previous topics to see that. See here, zinc, which is a solid, plus 2H. See, this is the oxidation state 0, and hydrogen, this is 1. Because this is proton, see, for individual elements, the oxidation state is always 0. Since this is H plus, it is taken as plus 1. Zinc 2 plus, so plus 2. H2, that is just an element, so it's 0. So what is reduced is the oxidizing agent. So H plus oxidizes zinc by taking electrons from it. So what is oxidized is the reducing agent. So zinc reduces H plus by giving its electrons. So zinc, you see, from 0 it goes up to plus 2. Hydrogen plus 1, it reduces to 0. Okay. Now what is meant by cell reaction? That is a full complete reaction that is taking place in the cell. So we write it on assumption that right side electrode always is taken as the cathode, and the spontaneous reaction is the one in which reduction happens in the right hand side or compartment. See, oxidation part, what happens? Zn. So Zn2 plus 2 electrons, that is the anode, and reduction takes place at the cathode. That is 2 electrons accepted by Cu2 plus, forming, because it accepts 2 electrons, means this 2 plus charge will cancel out, so making copper just into an element. Okay, overall reaction, what happens? Just look here, Zn plus Cu2 plus gives here Zn2 plus copper. So this is the cell representation. See, zinc, then Zn2 plus, then // Cu2 plus slash Cu. This is the cell representation. That is the overall reaction taking place here. Now Nernst equation, that's very important after the German chemist Walter Nernst. He established very important relation between energy or potential of a cell to the concentration of the participating ion. So E is equal to E0 minus RT by NF Ln anode by cathode. E is equal to E0 minus, the value for this is 2.303 RT by NF. So Ln, see why you are putting 2.303 to change Ln to log form, anode by cathode. See, these two are different, Ln and log is different. I am sure mathematics students knows that. We need not go into very deep explanation for this. Just remember, to change Ln to log, just put 2.303. Okay, now galvanic cell. What are galvanic cells? These are devices that gives energy of the spontaneous reaction is converted to electrical work. So it's used to run a motor or other gadgets like heater, fan, geyser and all that. We already discussed Daniel cell in one. It's such cell which the following redox reaction occurs. The zinc plus, we already saw this reaction just now, Cu2 plus gives Zn2 plus Cu. So the reaction of combination of two half reaction. What is half reaction? Oxidation part and reduction part, whose addition gives the overall reaction. So reduction and oxidation together will give the total overall reaction of the cell. So the reactions will happen in two different portions of the Daniel cell. Reduction half reaction occurs on copper electrode and oxidation half reaction occurs at the zinc electrode. So these portions are also known as half cells or redox couples. The copper electrode is called the reduction half cell and zinc electron is called the oxidation half cell. Very important points have given here, just remember it well. Now what is the electrode potential? That is the difference between the electrodes of the cathode and anode, also known as the EMF, electromotive force. Now activity series is the list of elements like metals or non-metals in which elements are arranged in the order of their reactivity. Okay, now we will just go through a small numerical here. See, represent the cell in which reaction taking place, Mg plus 2Ag plus 0.0001 m gives Mg2 plus, that is value is given 0.130 m. 2Ag, you have to calculate the E cell. E0 is given as 3.17. Okay, just straight away write the equation. It's quite easy. So E0 value given, substitute here. Okay, then RT by 2F log 2 plus by this thing. So value is given 2 plus value 0.130. This value is given. See 0.0001 here. See, look, for Ag it is given. So it is, since it is 2F, multiply that with 2. E cell you get the value by calculations, and finally this is 2.96 volt. Okay, now E0 cell is known as standard cell potential. That is also known as electromotive force, cell voltage, cell potential between two half cells. It is measured in volts. So how will you get E0 cell? It can be calculated by E0 cathode minus E0 anode. Okay, you can see the cell diagram here. Now just a representation, it's very easy. Anode, you have got the copper, then Cu2 plus here in the solution, here silver as the cathode. This is the salt bridge. See, look here, KNO3. Okay, this is the voltmeter. You can straight away take the reading over here. Now here Daniel cell, when you apply an external voltage, E external opposing the cell potential, you can see here this is less than 1.1, here this is E external is 1.1. So when it is less than 1.1, electrons will flow from zinc to copper, from here to here. So the current flows from copper to zinc, opposite direction is the current flow. And zinc dissolves at anode and copper gets deposited at the cathode. Okay, and here there is no current flow and no chemical reaction. Remember this point quite well. Now see, some important points I have given here is, each half cells has got a metallic electrode which is dipped into electrolyte. So two half cells are connected by a metallic wire. We have got a voltmeter and switch externally. Then electrolytes of the two half cells they are connected internally also through a salt bridge. We have got an external connection as well as an internal connection. So sometimes both electrons dip in the same electrolyte solution, and here we do not require a salt bridge. So remember that. Then at each electrode electrolyte interface, at that point some metal ions from the solution will get deposited to the metal electrode and trying to make it positively charged. So Same time, metal atoms of the electrode have a tendency to go into the solution as ions, and they leave behind the electrons at the electrode, trying to make the electrode negatively charged. What happens at equilibrium? There is a separation of charges, and depending on the tendencies of two opposing reactions, electrode can be positively or negatively charged with the respect to the solution. The potential difference will happen when between the electrolyte and the electrode, that is known as the electrode potential. So when the concentration of all the species involved in half cell, it is unity, then we call the electrode potential as standard electrode potential. According to IUPAC, standard reduction potential is now known as standard electrode potential. In galvanic cell, half cell in which oxidation takes place is called anode, and it has got negative potential with respect to the solution. So other half cell where reduction takes place is called cathode. It has positive potential with respect to the solution. So there exists a potential difference between two electrons, and as soon as the switch is in on position, electrons flow from negative electron to positive electron. The direction of the current flow is opposite to that of the electron flow. This is very important concept of electrochemistry. Please all of you go through this really carefully. Now the potential difference between two electrodes of galvanic cell, we call it a cell potential, and it's measured in volts. Cell potential is the difference between electrode potential of the cathode and the anode. Why it is called the cell EMF? Because when no current is drawn through the cell, we call it cell electromotive force. Now an accepted convention that if we give the anode on the left and the cathode on the right, while representing the galvanic cell is normally represented by putting a vertical line between metal and electrolyte solution, and putting a double vertical line between two electrolytes connected by a salt bridge. So all of it is shown in the diagram, just go through it. So using this convention, electromotive force of the cell is positive, and it's given by the potential of half cell on right side minus potential of half cell on the left side. So equation is given here, E right minus E left. So cell reaction, if you take Cu plus Ag, we already saw that half reaction cathode reduction takes place, Ag plus 2 electrons gives Ag, anode oxidation Cu gives out 2 electrons to give Cu2 plus. So we can see that the sum of the above reaction will give you the overall reaction, and silver electrode act as cathode and copper electrode act as anode. So the cell can be shown as Cu2 plus Ag plus Ag. So thus we can form the cell reaction. Okay, now what is EMF? The potential difference between the anode and cathode is called EMF. So it's also called cell potential, and we call it E cell. Okay, now voltaic cell, very important. So once even one electrons flow from anode to cathode, charges in these two beakers will not be balanced, and the flow of electrons would stop. So this side it is cation, this is anion. You can see zinc anode, voltmeter, copper cathode, and all that. Salt bridge is also given here. Okay, now oxidizing and reducing agent. So here the strongest oxidizers have most positive reduction potential, and strongest reducers have strongest reduction potential. The strongest oxidizing agent here, most positive values, and here increasing strength of reducing agent and increasing strength of oxidizing agent. You can go through this figure well. Okay, now oxidizing and reducing agent, greater the difference between the two, greater will be the voltage of the cell. So just remember that, and you can see the values calculated here, 0.34, 0.76, you subtract it, you get 1.1 volt. Now what is cell potential for oxidation? E0 red is minus 0.76, and for reduction red it is 0.34. Then the equation is given here, voltmeter is given, and we have got the switch and all that. Just go through this figure. Now if the standard electron potential of an electron is greater than 0, then its reduced form is more stable compared to hydrogen gas. If the standard electron potential is negative, then hydrogen gas is more stable than the reduced form of the species. So we can see that standard electron potential for fluorine is highest. It's showing that fluorine has maximum tendency to get reduced to fluoride ions, and fluorine gas is the strongest oxidizing agent, and fluoride ion is the weakest reducing agent. Remember that lithium has lowest electron potential, and which shows lithium ion is weakest oxidizing agent, and lithium metal is powerful reducing agent in aqueous solution. So as we go up from top to bottom, standard electron potential decreases, and with this decreases the oxidizing power. of the species on the left and increases the reducing power of the species on the right hand side of the reaction. So these are usually used for finding the pH of solution, solubility product, equilibrium constant, other thermodynamic properties and potentiometric titrations. Okay, with that we are coming to the conclusion of the part 1 of electrochemistry. I have divided this topic into 3 parts for your convenience. So once you have covered this, soon I will be uploading the next 2 parts, and please do like, share and subscribe to my channel, and I will be coming up with more interesting videos and uploading the lessons earliest for your exams. With that we are coming to a conclusion of today's lesson, and I hope you all enjoyed learning this very much today with me. Thanks for watching.